I'm talking about automation dog food, what basically how we use automation in the Gradle team. Does it? Yeah, it works. Yeah, just showing you some insights about how we develop the Gradle open source tool. Yeah, maybe you get some ideas what you could do. Short intro about me. We just have 45 minutes, so I keep it short. My name is René Gröschke. I'm working for GradleInc now for 3 years, more or less 3 years. Living in Berlin, in the old continent. Yeah, and I have no pets. About this talk, yeah, again, we want to provide some insights. We gave this talk before, but I think it's always a good, I think it's always a good talk, and yeah, people want to see it, obviously. So maybe it inspires you in what you can do in terms of automation in your project, and maybe, yeah, let's see if you are impressed or not. Maybe we can discuss, or maybe you have even better ideas how to do different kind of things. So first, let me tell you a bit more about the Gradle project itself, so how we work and how we are set up. At the moment, we are more or less, I think, 12 distributed full-time engineers working on the Gradle code base. By distributed, I mean, I think 7 time zones, 12 people, 7 time zones. We have frequent releases. Our aim is 6 to 8 weeks. Yeah, don't judge me by that, since you're waiting for 2.5, I guess. We have about 15K unit and integration tests, and about 60 modules at the moment. That's building up the Gradle code base. We have about 550,000 lines of code, plenty of comments, and as you can see, it's growing steady. And what we faced in the last couple of months is that we are continuously raising the number of commits per month. So at the moment we are at something like 600-700 commits per month. That's how the Gradle project looks like. Yeah, so why is automation key for us? I think it's critical for high-performing teams. So if you really want to work without distraction, you want to automate all that stuff that keeps you slow, and all the repetitive failure things where you can fail on, you want to automate that. For us, or the way we do it, is that automation is everyone's responsibility. So we have basically we have everybody in our team is called the Gradle principal engineer, more or less, and we have the same roles. And so there's no one responsible for automating things. And the way we do it in general is that it's a continuous development. So like when we do the release next time for the Gradle 2.5, we have automated more stuff than we had automated in the 2.3 release or something like this. So if something pops up, we integrate that in our development process. Or if something there's a new need to automate something, then we implement that. And it's a continuous thing you never done with automation, I guess. Yeah. So I tackle different parts of our environment and want to show how we use automation there, or what we automated there. So first, let's take a look at the development environment. IDE setup. When we do IDE setup, we're using obviously the Gradle IDEA task. So we use IDEA. I think all engineers use IDEA to do their coding. I think we have no one using Eclipse, but it should work. And the only prerequisite we have for running Gradle is that you have Java installed. So we haven't automated that one, but usually that wasn't an issue for anybody who joined Gradle. So you know the basic setup, what the IDEA task can do for you. So you can generate your class path, your project stuff, and stuff like this. We did a bit more. So if you run Gradle idea on the Gradle code base. What we do, maybe I can show you. We automated a couple of more things in it. Since in Gradle you have access to that XML layer of the idea task to generate all custom types. So what we, for example, do, or some samples what we do, we configure the Git setup so you don't have the annoying VCS apply pop-up thingy. We also generate automatically a run configuration. So when you clone Gradle from GitHub and you run Gradle idea, you get automatically these 4 setups. Gradle is just invoking Gradle from the command line, so easy, or the best way to debug for us, debug things which are reported. Then there's a quick check, which is some sort of a build we use locally for the developers to have fast feedback. And then we have some regenerate tasks. For example, regenerate a full Gradle distribution to use locally to test against. Later on, I show you how we use that. And we do plenty of stuff more. So we set up our code, our quality plugins to configure how the code should look like. We set copyright, and where it was really convenient was when IDEA just released IDEA 14.1.3. There was Gradle IDEA 14.1.3 has an issue with the Groovy compilation, and it was really easy for us to fix that. Basically, all we needed to do is provide or change our automation to provide that flag to the Groovy compiler, and we could easily continue working without waiting for the JetBrains guys to fix that or manually configure that stuff. So that's something, that's a nice thing to do. And everybody has the same setup. So if you generate the same runtime configuration, with your colleagues, you're talking about exactly the same stuff, right? You say, I use that runtime configuration to do things, and things broke. And it's way easier to reproduce that stuff. Yeah, that's the first thing, obviously, we do. When it comes to testing, yeah, I haven't found a better word than nerd here. We had a lot of, or we still have a lot of test nerds on board. So we used to work with, or I think I was, apart from Hans, founding Gradle, I was the first guy who didn't wrote his own test framework, who joined Gradleware. Like the first one, Peter Niederweiser, who's the author of Spock, joined Gradle. Unfortunately, he left us. Then Stepan Faber doing Mockito. Is he here? No. Yeah, the LinkedIn guys grabbed him. But we still have like Des, who did Selenium, and we had Luke, who does JEP, the web testing framework based on Spock. So, and we use Spock for writing all our tests, our unit tests and our integration tests. And that's a general pattern. We write more and more code, or we have a lot of Java code. People tend to say that Gradle is a Groovy project, but more or less it's really a Java project, in my opinion. But we have a huge Groovy code base on the outer layer, maybe some things like plugins, but the most stuff we do with Gradle or with Groovy is testing our stuff. Yeah, that unit test, I guess I don't need to show a Spock unit test. That's not that fancy. When it comes to integration test, I think what the most important thing about having integration tests is, or supporting integration tests, that it must be extremely simple to write an integration test for you, because that lowers the barrier for you to write something. And for us, if we got a report in our forum or on the dev list or whatever, it's very simple for us to write an integration test against it. Let me demo that, how integration testing looks like in Gradle. So I can write an integration test from scratch here. I go to the core, and let's say I want to write a test for some core functionality. And what I can do is, just write a new Gradle Summit integration test. Yeah. And what we can do, we have a lot of test fixtures written, and one of them is the abstract integration spec, which is a Spock-based base class for testing. And what you can do is, how that looks like is, let's say I can greet Gradle Summit. What we try to have the same pattern for our tests, so we do it. Spock provides labels. Labels is basically a Java feature nobody uses. Who's doing Java and uses labels? Yeah, exactly. So, but what you can do is pardon? Who does? Nobody. Okay. So our tests more or less look always the same. So we have something like given, that's a prerequisite of your test. So I have a build file, and what I can do here is I create a task, greet, which just does print line, hello, oh, German, sorry, Summit, from the Summit. So that's my prerequisite, and then I can say, okay, given I have that build file with that content in it, and when I run the greet task, then given when, then I want the output to contain that stuff here. So always we have that given when then structure for our test, or almost always. And when I run that stuff, yeah, here you see Gradle gets executed, and the output variable contains all the command line output, and we can validate against it. So that's the easiest way. So you just need 10 lines of code to write a unit test or an integration test in Gradle. And that's very important for us. So, and that makes it very easy for us to, if somebody has a reprod, when we somebody who of you is in the forum, yeah, go ahead.
This base class, abstract integration spec, is this something internal, or is it something that plugin developers can also use?
It's completely internal at the moment. We have plans with bringing support for doing that more easily with providing some features for the customer or for the users. We work closely with the Netflix guys. Are the Netflix guys here? They provide some feature, or they have a plugin for testing or doing integration tests for Gradle, but they don't want to maintain that anymore. And so we are currently in the process of adding that stuff to the Gradle code base. I don't know how. You have to grab Ben. He wrote the spec for that. So if you want to have more details, so that's basically a very easy one. So and it's just written on the command line. But what you usually have is we deal with a lot of external systems, like obviously Maven repositories, and the way at the beginning when Gradle was based on Ivy under the hood, we had basically no idea how many HTTP requests we do, and we have no idea how, when we change some stuff, how that reflects in terms of performance. So what we did then is we completely got rid of, or the issue was that Ivy was getting worse and worse for us. And if you request a snapshot version with Ivy in that version we used at that point, it did something like, don't get me, I don't know it in detail, but I think something like 15 HTTP requests to figuring out what the right version is. So we started working on that on our own. And for example, we have to ensure when we work on the dependency management stuff, and maybe you attended the talk from from Ben, where he talked about what we currently want to do or what are our plans for improving dependency management. And we have to ensure that we don't downgrade anything, or that we don't accidentally add another HTTP request, which is just expensive. So, for example, what we do here, let's go to that one. So here have a more really integration test from our code base. Basically, the cache is, or it's self-explaining, right? You can resolve and cache dependency from an HTTP repository. And if we execute that, we see that running. But the most interesting part here is that we introduce our own test fixtures for mocking all that Maven HTTP stuff. And we have the same stuff for SFTP, and we have the same stuff for S3 storage. So, and here we say we set up, what we basically do is we start a local server in doing that stuff. But what we also do is we at a very low level, we tell the test here, do we expect a GET? Do we expect a HEAD request? Okay, we want to have a GET on that artifact, on that POM file, and that's something that makes us really confident in working on that dependency management code base, because we don't introduce accidentally some more requests and stuff like this. Yeah, that's just small intro to our integration tests. Yeah, again, if you have integration tests, you have to ensure that they are simple. Well, it's easy to say for Gradle, because Gradle is a command line tool, which makes it way easier to invoke, like, I don't know if you have distributed systems, whatever. Yeah, but you should work on that. The other thing is that in Gradle, we can run every integration test, or what we do not from the machine locally, but in our test CI server machines. We run the integration test in 4 different modes. So basically, when you work on the command line, use the embedded mode, or in the IDE, sorry, because you want to debug everything, how the test works, and you want to do that. The issue is with running embedded is that it's not reflecting the reality how Gradle invokes tests, for example. When you invoke a test in Gradle, you fork a new JVM, and you run all the tests in a completely separated test VM. So we added a different mode, and now you can run your tests in forking mode. And if you run tests in forking mode, they're way slower, because you have that ramp up of building all that processes, but they're way more realistic. And since they are running on the CI machine, I don't care. And the other stuff is, when we introduce a daemon, who's using the daemon or who's not using the daemon? You should. Then we also change our test to run in daemon mode, and that's a perfect stress test for our daemon functionality. And the other thing is, when we started working on parallel support for running -- parallel, we run all our test suite and all our builds with that -- parallel flag to see that if we broke something in some way of error. Of course, we have dedicated tests for testing the parallel functionality, but it was tremendously helpful to just enable that for every single test. So we have around, I don't know, 11,000 integration tests, and you can see that that's really a good base to test that parallel support with all the different stuff.
How do you deal with backward compatibility stuff? That seems tough.
The question was, how do we deal with backwards compatibility stuff? Because that seems tough. What's tough in terms of when you work on?
Whenever you make a change, you're trying to maintain backward compatibility with old
Yeah.
sort of specs that you released in the past, and your tests have to kind of cover and make sure that works across versions. So I'm just wondering if you do anything to manage making sure all these different versions work.
We talk a bit about that later, but in general, well, you have a new functionality, you had a new test, right? So you keep the old one to ensure that, I don't know, maybe did I get something wrong? Yeah, and the way we do that, or there's nothing fancy about running that in different modes. We use the, where is my, So the way we are doing this is just using, yeah, exactly. We can run forking, intake test. We use Gradle, shit, I forgot the name. My brain shutting down, I haven't slept a lot. We're using these task, what the fuck? Task pattern. I want shit, I forgot the name. Task rules, sorry, completely off. We use task rules for implementing that, so we have intake test, and if it starts with something else, we invoke different flags to use that stuff. Yeah, basically that's. So what we have in terms of when we have some issues with dealing with compatibility things, like we testing against, again, we integrate against different tools, like not just Maven repositories, but support for different JUnit versions or different Groovy versions or different, I don't know, all our checks, our code quality plugins support different versions, and we have to ensure that they work. That's one thing we need to test. We do need to test cross-version test or have cross-version testing there. And the way we do that is, let's take a look at how we do JUnit testing. Cross. Let me multi-version. So we introduce again some Gradle internal test fixtures to deal with that. Basically, here we have what we call a multi-version integration spec, which is just a specific version of that abstract spec. And what you can do, what we define on top of that is which JUnit versions we want to test against. So we want to have large coverage, which means we want to test against 4.0, 4.4, 4.8.2, and the newest one. The newest one is, yeah. Is that even the newest one? I don't know. And what we have when we run that test, we just spawn different processes or different, test cases based on the versions. And if you run that locally, it will, usually if you just run it locally, it just uses the latest one to keep the IDE fast. But let me try. But if I do that, oh, excellent. Plugins, intake test, test. Yeah, however, then we fork multiple tests to run the same test against different versions. Maybe I can show that on our CI machine. Yeah, the other thing that's just, or the issue with those kind of support is that we just have, you just need backwards compatibility, right? And that's something everybody gets. Everybody knows what backwards compatibility thing is. The problem we also have is that for the tooling API, the tooling API is a library provided by Gradle, part of the Gradle codebase, to invoke Gradle programmatically. And the idea is that you have a consumer and you have a producer. The consumer is basically the client you use, and what that one does is it connects to Gradle installation or Gradle process, and you can programmatically do something with it. And there, what we have there is we have backwards compatibility. So if you invoke it with a Gradle 2.4 consumer library, we have to ensure that it works with all former Gradle versions, right? You don't want to have a one-to-one relationship there. But the other thing, the more interesting thing is that you also want to ensure that if somebody's using the tooling API in version 1.12, we want to ensure that Gradle 2.4 does not break anything. So that if, for example, the former Eclipse support was based on a fixed version of the tooling API, and just if we release a new Gradle version, we don't want to break that support. And what we have to do for that is tooling API. Let's take, for example, that one. Can build the Eclipse model with the Java project that's using the tooling API. And the way that test looks like when we run it is that plenty of stuff. So you have different incarnations of that test. Here we test current against current, which means whatever I have checked out in my current workspace, we test that tooling API against that Gradle installation. But we have also here, we tested locally again, we try to reduce the overhead, so we test just against the latest released Gradle version, so that it's still working, and the other way around, I changed, fuck. I broke something. I haven't generated the int test image. That's why I need that intake test image. That's the one we're testing against if we use the other test case. Yeah, so we provide forward compatibility, which is really hard to maintain sometimes. I just work on the tooling API and you think you're done, and no, you're not. Yeah. Yeah, and the pattern we have maybe does the pattern we have here is once I want to provide this talk with a green CI box, but almost. So yeah, if you go here, or what we have then, sorry, is we have a specific cross-version test where we really ensure that all different versions and version combinations are running. And if we go to the latest one, I don't know, take that one, test. And here you see we test, like that one, we test against even Gradle 1.0, that it's working, using 1.0 against 1.2, and the same stuff here. And sometimes we add features and we break something. So what we can do, what we always can do is, like I'm currently working on tooling. Oh shit, I broke that last night. The way we organize our test for the tooling API stuff to ensure that we know what version we need to support is we maintain our integration test stuff to reflect the version where the feature was added, something like this. So we have we even support Gradle 1.0 milestone 3, which is, I don't know how old. I think before I joined even. And if we have something new functionality, so if you add functionality on top, you can't obviously test against older Gradle versions. But there we have, there we have another custom thing where we say, okay, here you can use a tooling API version newer than 2.5, and you can run it against all Gradle versions till milestone 1.0 milestone 8. So we can limit the permutations we want to test against. Yeah. Yeah, that's about cross-version testing. We also test our distribution. So that is basically the last safety net we have for if something went wrong with creating that distribution. Basically, we do some checks if the expected layout is there, and we do something like we check the size so that we are aware of if somebody adds some dependency on it, and currently I think Gradle is about 60 megabytes or so when you download it, like we added support for S3, and we needed to, if you want to support S3, you need a lot of libraries, and this one broke, and this was the one who tells us, well, that there's something wrong. We want to support Maven S3-based repositories, and we need 15 megabyte to put on top of the base Gradle distribution for that. It's not a corner edge, but it's really a limited use case for that. And that's the safety net which made us aware of that kind of stuff. Yeah, performance testing. How do we ensure that we don't add any regressions? So we wrote our integration test. We don't use any particular framework for that. Again, we use more or less Spock for doing that. And we run it every night. We run a performance test on Windows, and we run a performance test on Linux machines. And what we do for that is we have a subset of, or we have a set of sample projects which reflect some specific use case of Gradle. For example, we want to ensure that a small Java project, something like, I don't know, comments, utils, that we are really fast on that, and we have no regressions in that. So we have a sample build that just is a small Java project. So, and we have the same thing if we need to test against, if we have a huge dependency tree with 500 dependencies in it and something like this, and which a deep nested dependency graph, we test against something like this. Or especially when we start working with the, sorry, that's a wrong run. When we start working together with the Google guys, we started to model their use case of having different variants and kind of stuff in our performance builds. And where do I have that one? Yeah. And what we generate out of that stuff, yeah, again, everything implemented by our own, nothing, we used no library, maybe we should have. You get some sort of report where it's saying, okay, what we do with every test, we run not just the latest one, we run all versions, because you have the problem if your underlying infrastructure has a hiccup, or I don't know, something is going on that CI machine, or you just use a newer machine, you want to have compatible, or you want to be able to compare it. So every performance test, so every time we run against the 2.0 version or the older versions, and we compare it on that machine to that timestamp, let's say. That makes it easy to compare them. Otherwise, it doesn't make sense. If we just add an SSD to our build machines, accidentally 2.4 would be faster. That does not work. So we need something better. And what you get here is, yeah, you get information like how many seconds we used, and that's basically demoing what Hans yesterday told, that we had made huge performance improvements in 2.4. And we also track memory. And if you want to see that in the long term, you can regenerate something like this. And here you see the difference between the 2.4 version, which is there, and the 2.3 version, which was there. So that's how we do performance testing. Basically, if you look at our build server, it's red. Everything is broken. The reason for that is, or one reason for that is, after we release a new version, we tied the timing, right? If the last version was the fastest Gradle version ever, and our test base, so the basement to test against is now 2.4, so it's way harder to fix that or to match that. Usually, yeah, that takes specific kind of effort to do that, and you also have to make compromises on that, right? Like we added that project that, I don't know if you saw that talk from Des, where he talked about replacing project dependencies with external dependency with that fluent dependency management. That has some minor effect on the performance, but the feature is so cool that we can deal with, I don't know, 50 milliseconds or so. That's worth the effort, and that's a judgment call you always have to make. Yep, that's performance testing. One other thing we test is our documentation. So basically, we generate, or if you see in Gradle samples, like let me take the copy task for example. If you go here, or if you look at the Java doc, you see sample code snippets, how it's supposed to work. And if you have a typo there, usually the typo would get into the official documentation. And since we don't want to have that, so we need something to test that. So what we introduce is we run tests against our Java doc. So here, what this task is doing, or this test is doing, it checks all the sources of the core project and runs tests against these classes. If there's any snippet in the Java doc, we run against it. So it takes some time, but to make it a bit faster, we can just include the copy task to demo that stuff. So here you see we found a sample task copy docs, which is that one here, and it passes. So there's no typo in there. There's nothing wrong. You can basically paste that from the documentation, and we ensure that it's working. And if I do something like, I don't know, something not supported, I don't know, if you type anything there, and I run it again, please break. Yeah, okay, cool. Yeah, the build fails. So we can always ensure that all our snippets we're doing or showing in the Java doc are actually, we don't test them completely in terms of we don't generate the source and we don't test the copy task. That's where our other integration tests are for, but we just ensure that the syntax is right? That we catch the most common issues. Again, I talked about the tooling API. There we have a tiny different use case. So let's say I take a look at that project connection, which is the entry point for that. And here we have Java code, right? That before was build.gradle samples file, and that is Java code for documenting how the tooling API works. And what you can do there is, that test looks a bit different. So what we do here is, we create some sort of a skeleton around that snippet where we do the usual imports you need, like the tooling model stuff, a sample class, and then we just paste the sample in that main method. Then we compile the sources and see if the compilation works. Again, we don't test the invocation, we just ensure that the syntax is right. If you grab the Gradle all distribution, there are also samples in there, which are tested automatically. So for these ones, we really invoke them and test that they are working. Samples integration test, like for that announce one. And there we also put additional logic. We don't just test for that the syntax is right, so we don't just run Gradle tasks. We can add specific tests for that. So here we add that init script to invoke additional logic to our samples to validate that stuff. And then we check the results that there's a hello world output generated. That's how we test our documentation. How much time do I have? Okay. We have plenty of documentation to provide. We have a user guide which references these samples. So again, we ensure that this user guide has all the correct samples and they are tested. So you can really paste them and they work. And then we have that DSL reference. At the moment, we use DocBook for generating most of that documentation. And for that DSL reference, what we actually do is we implemented parsers for parsing the source code and mixing that stuff into the Dogbook implementation. We're currently looking into making that maybe more convenient and to make it more reusable for our other projects like the tooling team or the SaaS offering, the Gradle.com guys. Yeah, and there has a lot of stuff happening around that documentation thingy. We often get messages or we're asked if we can provide that stuff to be used by the users. It's pretty specific to our use case in terms of that not often people need to generate the DSL, so we don't really need to parse source code. What I usually recommend, if you want to automate your documentation, you should take a look at ASCII Doctor, which is a really cool tool for doing automation or to doing, first of all, documentation, and they have built-in support to run tests against snippets, or they have functionality to tie testing of your documentation into your documentation. So take a look at ASCII Doctor. There's a Gradle plugin out there for this. This slide deck is basically ASCII Doctor generate. It's really the tool I would use there. RP reference is more or less the same thing. Java doc and Groovy doc stuff, nothing special. And the release notes, well, did I have a picture of that? Not. Yeah, what the process for us is in terms of generating release notes is that it's not that, okay, we want to release 2.5, shit, somebody has to write this release notes. Release notes are part of the feature development we do. So if I change something like, I don't know, the last thing I worked on, Eclipse class path generation, maybe, Adam or somebody else who's reviewing my stuff will just tick off that review if I edit breaking changes or new functionality to the documentation. So it's part of the development process that you take care of your documentation. It's nothing specific. And we don't have the resources for people just writing documentation and hunting us engineers to figure out what it does. And that doesn't make sense, in my opinion. So it's really integral part of that engineering. We have some code quality stuff we use, obviously. We have a sanity check build, which is a really short one, where we just ensure that, oh, nice. I think that was me. Yeah, that's just a 3 minutes one. It's just checking check style stuff. So if the check style is wrong, we don't even start our pipeline. It doesn't make sense for us. I think I have a... and what we also do is we apply all our sanity checks, like test coverage and not test coverage, but check style and Groovy code narc rules on our build logic code. So we have a huge folder of we run Gradle build, or maybe Gradle tasks here. Yeah, basically what you can see here is that we run check style and we have plenty of tests we test against, so we also apply that logic to our own build code. We currently have no code coverage. Basically, I'm not sure if code coverage is really a metric you need to track. Some people are really curious about that. But what I noticed when I was at client, that managers say, well, we need the code coverage of this and that number. I don't know, 60%. But in my opinion, that metric doesn't make sense at all. That's my gut feel. It's a completely overrated metric, in my opinion. And I guess it would be, yeah, I don't know, something around 95 thingy, or maybe. Stepan already said it would be 100, maybe, I don't know. Maybe short, I'm almost done. The build pipeline, how we do our pipeline at all. So when you commit something in Gradle, or if we commit something, what we introduce is we have some sort of, where is that? We have some sort of quality gates. For example, the first quality gate is a commit stage where you say, okay, it's basically working on Windows and and Linux, and you have the check styles right, and most of the basic tests are working. It's basically what you do, what you run on the command line. Also, that's the first check. That's the first quality gate, and we have 4 of them, and the last one is more or less having full coverage. The problem with our pipeline, or what we need to test when you commit something in Gradle, that we support different Java versions, and we support different, obviously, operating systems. So we have no specific target system, and we have to test against the whole matrix of systems. And how that looks like is basically maybe do that something different. Let's find a different view.
Question,
Yeah.
how do you know which tasks belong to which quality gate? Do you store them in different folders in your repository?
Basically, we run all tests in all quality gates, but just with different. For example, in the first quality gate, which is a commit stage, we just run it similar to what we have on what I showed earlier. We run, let's say, against the latest JUnit version to make that fast and not the full coverage against 4.0. And then later, if we have coverage builds, what we call them. So basically, that's how the pipeline looks like. And then you have those coverage builds, which do plenty of more stuff. Or here you see you have now coverage for Java, Windows, Java 1.7, and running in daemon mode. And we have Windows and Java 8, which is just a quick check. And we have, where's the Linux coverage? Okay, it's basically that's the other stage. And here, if you look at the build chain, what we don't do, we don't run against all permutations because we can't deal with that. We have Java 1.6, 1.7, 1.8, and now we test also against Java 1.9. And we have you have different, and it's not just that. You have we support IBM JDK, and you have to test these 1 too, and then you have Windows. So that matrix, it would take ages. So we just say, okay, we run that Windows test with that daemon integration test mode, and run that cross-version test. Okay, it's fair enough to run that against Java 1.8, and that gives us enough feedback to say, okay, it's working. If something gets through this tiny holes, okay, then that might happen, but it's really rare. Yeah, we do our pipeline basically with TeamCity. I think it's really a tool I can recommend, but we could do that with all the other stuff. And what we do is when we do a release, we have basically 2 branches. We have master and release, so everybody's working on the master. Everybody's pushing all his stuff to master every time. So who was that guy? Somebody, I attended the talk of that guy who wrote that continuous delivery book, that famous one. Exactly, Humble. It's too bad that he's always mentioned because the second one was, how is that name? Yeah, yeah. Who knows the second? Okay, somebody did. But it's too bad for him that everybody says just Humble. And he said, well, if you don't commit to the master branch once a day, you don't do continuous integration. That's what he said. And I think I agree to that. And what we do then is everybody's working on master, and when we say, okay, we need to polish some stuff, or we want to introduce some really feature which can break the build for a couple of times, or introduce some massive new stuff, and we just want to polish, then we branch the release branch and just do tiny things like, okay, we need the final tweak of the release notes or at the intro paragraph or something like this. That's what we do on the release branch. But we have exactly the similar pipeline. For the promotion or how we do a release, basically, yeah, I can demo that. Basically not able to run a release, but it should be It's here. If I go to that build here,
Do you have a diagram of your branches? How you
we just have two.
just
We just have master and release. And once a release is done, or we really take care of merging master back to, or release back to master. And then that's it. So, yeah, how we do a release is basically we say promote here, and then I say, I want to do refine a release. We have a specific, we used to, for the PR stuff, pull requests. The question was how we deal with pull requests. The first thing we added was a build to run against that pull request to see if something breaks. If it breaks, we just say, hey guy, we don't take a closer look on that because it's really, it takes a lot of time to maintain pull requests. It's really underestimated thing, in my opinion. But we run tests on Travis CI. Automatically, it integrates with GitHub. But now we started moving away and having a separate specific jobs running the basic coverage on our TeamCity against pull requests. How we do code reviews is that, again, everybody commits against master. And the way we organize it is, if you consider a story is done, you mark it as ready to review. And you as a developer are responsible to get somebody to review your code. So you grab some of the other developers, you do together a review, and then you might decide to fix something. We use Crucible, which I'm not opinion about that. Basically, it's really, it's okay. And then the final, there's Adam usually, which is our CTO, he usually takes a last look on that stuff. But it could happen that you already released it. So it's just for the long-term thing in terms of, okay, he often has different picture in mind or has other stuff in mind what we need to consider. And then he does a last thing, and then that's how we do it. Last slide. Yeah, we have around 20 build agents, Linux, Windows build machines. We use Salt to manage them. And we also have some integration with our new forum. Happily, we moved to Discourse, which is an excellent framework for, or excellent tool for doing technical discussions. And they were really helpful with helping us with start writing plugins. Basically, I'm a JVM guy, and the Discourse stuff is based on Rails and Ember.js. But yeah, you can just ask them, and they write the plugin for you. That's really nice. Yeah, that's basically it. Thank you for attending.